Okay, so let's give you guys some more practice. So here, find dy by dx of this. Okay, so if you get a graph plotter and plot this, it will look like this red graph here. So when you differentiate it, whatever your derivative is, you know it has to cross here somewhere. Because look, the gradient right here is 0. So you know your derivative must cross 0 here. It must cross 0 here. It must cross 0 here, and so on. Okay, so whatever your derivative is, if you plot the graph of your derivative, it should cross here, and it should cross here, and so on. Okay. Well, anyway, find dy by dx of this. So press pause and have a go. Okay. So to do this here, hang on. So to differentiate this here, visualize this bit here. Well, at the moment you've got something like this. At the moment you've got log of a over b here. So whenever you have this, you can immediately jump to this natural log of b here. So whenever you have this here, you can immediately jump to this. So this will be log of this. That's this bit here, and then take away the log of this. But then also visualize the square root as to the power of a half. So when you look at this here, you've got the natural log of the square root of blah blah blah. Take away the natural log of 1 minus natural log of x in here. But then this bit here, visualize as this, the natural log of the bubble to the power of a half. That's the same as the square root. So that's this bit here. Okay, and then because you've got the natural log of something to the power of a half, you can actually take it out here. So it looks like this. Okay, and then now it's just a matter of differentiating it. So hang on, let me just move this across. Hang on. Let me just move this across. So this would be yeah. So now we are here at the moment. So differentiate this. It will give you a half. This half here goes down here, and then this will be 1 over this thing here. But then because you've got you've got something that's a product. You've got something that is a function of x in here. You've got to use a product rule on this thing here. Okay, so here you got to use a product rule because you've got this thing multiplying with this thing here. So the product rule is differentiate this, leave this the same. So differentiating this will give you minus sine x, and then you times that sine x here. That's the first part, and then the second part is to leave this the same, which is cos of x, and then differentiate this, which will be cos of x. So merge these two together. That will give you cos squared of x, or cos x squared, and then you've got sine squared of x. So this here will give you this. Okay, and then this bit here will be 1. When you differentiate this here, it will be imagine it as a bubble here. So it's 1 over this thing here. And then because this is a function of x here, you've got to differentiate that as well. So you've got to times 1 over x. That's this 1 over x here. Okay, so if you differentiate this, it will give you this. Now it's just a matter of tidying up now. So this whole thing here gets multiplied to the top. So that will give you this here. And then bottom times bottom here, it will give you this. And then yeah, merge these two together. That will then give you this. Get a graph plotter, plot it, and the blue line represents your derivative. This red line here represents our first original graph. The blue line here represents our derivative, which is this thing here. So if you get a graph plotter and plot this, it will give you this. And then double check. So right at this point here, the derivative should be 0. So the derivative is 0. Right at this point here, the derivative should be 0. Right at this point here, the derivative should be 0. And then looking at this here, around here it's going uphill here. So the gradient is positive. So looking up here, the gradient is positive. Okay. Looking at this bit here, looking at the red line, here it's going downhill. So the gradient should be negative. So looking at this, the gradient here is going down here, it's negative. Okay, and then looking at this, the gradient's negative, 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 negative. So looking at the blue line, it's always negative, 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 and so on. So it does seem to be correct. Okay, our derivative here, looking at the graph, our derivative here seems to be correct. Okay.